Alright, this is problem number 4 of the free response from 2003. The questions, it gives us two equations, an x in terms of t and y in terms of t. The first question is find the velocity vector of the particle in terms of t and find the speed of the particle at time 0. So the first thing I'm going to do is take the derivative of x in respect to t and the derivative of y in respect to t. Yeah, so I just put those two equations, the first derivatives, up in the top right corner because those are two things we're probably going to use over and over again. A is find the velocity vector for the particle in terms of t, and then find the speed of the particle when t equals 0. So I guess it's easier actually to find the speed of the particle at t equals 0 because you're actually just plugging in 0 for t and all this, squaring the answer, and then taking the square root of those two added together. So you're going to get e to the 0 is always going to be 1, so it's 6 minus 7, negative 1 squared, which is 1, plus, I'll write it out, 1 plus, and then 9 plus 2, which is 11, and 11 squared is 121. And it's going to be the square root of all that, which is equal to the square root of 122. So that's going to be the speed at time equals t. And then, alright, so it seems like actually the velocity vector is really simple. It's just the x derivative comma y derivative, and we've done this. I screwed it up in class because I found the velocity vector at when t equals 0, but it's literally going to be this comma, so this is the entire x value, comma, yeah, so that's A. Now B is find dy dx in terms of t, and then find the limit of dy dx as t approaches infinity. So dy dx, I don't know if you remember this, but dy is just dy dt over dx dt. So that's going to be 9e to the 3t plus 2e to the negative 2t all over 6e to the 3t minus 7e to the negative 7t. So if you look at this part right here, the dy dx, which I'm actually going to write is equal to dy over dx. The limit of this as t approaches infinity, we're looking at the t's and how, as the numbers get really big, how they're going to act. So all we really need to look at is this here, which is 9e to the 3t over 6e to the 3t. And since they're both to the 3t, we're really just looking at the coefficients here. So the limit of dy dx as t approaches infinity is actually going to be 9 over 6, which is, you can simplify down to 3 over 2. Then C is find each value t at which the line tangent to the plane of the particle is horizontal, or explain why none exists. Sorry, I just had to rearrange the screen there. So, we're looking for a line tangent to the plane when that tangent line is horizontal. And at that moment, when the line is horizontal, dy dt is 0 because there's no change in dy dt at that moment, or there's no change in y at that moment, so that dy dt is equal to 0. So we're looking when 0 is equal to 9e to the 3t plus 2e to the negative 2t. And so this is actually, we're trying to explain why none exists, because there is no t value when this can ring true. And the reason that is because there is no t value when e will be when e will equal 0. And so since 2e to the negative 2t is always going to be larger than 0, and 9e to the 3t is always going to be larger than 0, when we add them together, they're always going to be larger than 0. So there's no t value when the line tangent is horizontal. So the way I'd write this out is because e to the t, I'm going to say e to the at can never equal 0, and they are being added together. And then d down here is very similar. It's just find the t value when the tangent line is vertical. So we're looking for when the tangent x is 0. So that's just 0 is equal to 6e to the 3t minus 7e to the negative 7t. Which is going to take a second to do, but it's, again, pretty simple. Alright, so this is a completely different story here because there's a negative sign. So really what we're looking for is when 7e to the negative 7t is equal to 6e to the 3t. And the way we're going to find that is just pretty straightforward algebra. So I'm going to do e to the 3t, and I'm switching sides here, over e to the negative 7t is equal to 7 over 6. And then we can take the log of both sides, and that's going to give us actually, I'm just going to do another step here. E to the 10t is equal to 7 over 6, and so ln of 7 over 6 is equal to 10t, and t is going to be equal to ln of 7 over 6 all over 10. So that's our answer, and I don't think this is a non-calculated question, so that's all you really need. Yeah, that's I think I'm done.